So start with your vertical asymptote. That's what's coming in your denominator. Your point of discontinuity is a factor that has to be in the numerator and the denominator because it has to cancel out. So start there too. Now, this guy is giving you an x squared. This guy is giving you an x. You have a horizontal asymptote of y equals -2. If it was 0, we would know the numerator was less than the denominator. Slant we're going to do today. But when they're equal, that's when you get the ratio. So set this up like a ratio so that you see it. So somewhere we have to have a -2 over here, and we need an x over here. Okay. Now, if I didn't have to worry about anything else, we would be fine. But we've got a point of discontinuity that has to fit into here. So there's our plus n. When you set this, this is your xy point. This is an x and a y. When you set this, get rid of this factor. It's going to cancel itself out even with the x substituted in there. So just take it out. This, set it equal to y, and plug in your x of -1 and your y of -4 and solve for n. Once you've done that, just go back and don't forget to put it back in. Now, technically, we're leaving these in factored form. If you want to factor this out, and I said to you yesterday, I'm okay if you leave it like that, because this way you can match it back up to what you did. Rohan, you might want to be listening to this, because this was new. So you could put your factors here. And don't forget to set it to some kind of equation. I'm okay with you right now leaving it with the 2x minus 10. When you go back and look at it, it kind of makes itself fit in a little bit better, but if you can remember to factor it, that would be one step better.
Just, where's the x plus 1 on the bottom from? I'm sorry, that's just the only thing I have wrong.
The x plus 1 came from this piece right here. This was a factor. And our point of discontinuity has to be in the numerator and in the denominator.
No, I used the 4 in it.
Oh, okay.
Yeah, I used the 4 instead of the 1.
Okay. We use the x part. The y part is what comes into play here. We don't know yet how to fit that in, so we do figure out everything else, and then the last step is plus n, and you'll figure it out. Questions? We're good with this? Okay. They're not so bad. They're a little bit nerve-wracking in the beginning, but you just got to get comfortable with it. Okay. Vertical asymptote, none. That means there's no restriction in my denominator. So I can't just have an x by itself or an x squared by itself. I have to have something that will give me no restriction. My horizontal asymptote is -3, which means I have this kind of situation. So I can start like that if you want. Start whichever way you feel that you need to get into this. I like to usually go to whatever they give me so I can get my factors in there first. And then I work my horizontal. So they didn't give you a point of discontinuity, but they gave you where your zeros are. According to your list, where do we find your zeros? In where? In your numerator. So set those equal to 0 and make your factors from this. This is going to give you an x squared. We also need to have a -3 up here and a 1 down here. So I need an x squared in the bottom. But remember, I can't use an x squared, because an x squared would give me a vertical asymptote. Plus 1, plus 4, whatever you want to make this. So plus 1, keep life easy, and just bring down your -3. Usually try to get your horizontal asymptote after you get all your factors down there, because you don't want to have to be changing it later. Does it make sense?
That's it?
That's it. Yeah, and set it equal to f of x, z of x, h of x, whatever you want to set it equal to. It's really not that bad as it looks when you get these parts to it, and the point of discontinuity. This slant one we're going to do today is the last time we learned. It's a little bit different, but I find it a little bit easier. It's a little strange looking, but actually a little easier to work out. So any questions so far? So just keep in mind all these conditions. We have a vertical asymptote. Where do I find this guy? Denominator. We have a slant asymptote somewhere over here. I had an x, I had a -1, I had a remainder that we said we didn't need your remainder, right? Okay, and this became our y equals. There is your slant asymptote. Where does your zeros go? In your numerator. Right? And this is all equal to. Now, I've got a little bit of a problem with the slant asymptote. My 0 is also one of my zeros, one of my roots that I divided by here for one of my x-intercepts. So I don't know what else is going up here, and this certainly doesn't help me with my slant because this one's the same as this one. Now what we do for your slant asymptote, we divide it. We took this and we took this equal to 0 and we divided to get here. So technically we're going to pretty much do the same thing. But we're going to start with this piece right here. We're going to take this, put your remainder over what? Over x minus 2. We've got to get back to that remainder. Slant asymptote work makes us work a little bit differently. We're going to build your equation right from this. It's a little strange when we start, but you'll get the hang of it. Now, we need a point to plug in. Remember how we did with your finding your formula for your parabolas? We needed to find A. We always need to find something. We need a point to plug in. Do we have a point that we could plug into this? 4, 0. One of our zeros. So we know my x-intercept somewhere was at 4, 0, right? My zeros, remember these guys, are my x-intercepts. If it was a y-intercept, it would be 0 with the y. If it's an x-intercept, it's x with the 0. So we have an x, we have a y. So we're going to plug this in. We need to find the remainder. It takes a little bit of time, but just bear with me. Follow along with me. Every time you see an x, plug in a 4. This, you do first. How do I get rid of a remainder? Multiply. Let's multiply everybody by 2. So r would be equal to what? -6. Now, where's the tricky part? Okay, you're going to take this r and you're going to replace it back into here. We're going to build everything right off of this. It all builds nicely. Bring this guy back over here. Excellent. We're going to build everything right through this. So here's my y equals. We have to get this over one denominator. What would be your common denominator? I should have drew this line straight like this. What's your common denominator? X minus 2. This guy has a denominator of 1. This guy has an x minus 2. Okay. This guy has a 1. Keep this in parentheses. It needs an x minus 2. This guy has an x minus 2. -6. We can kind of see there's your vertical asymptote. Yes?
For the 3 plus r over 2, why did you multiply 2 and 3? The way you did it or not?
Wait a minute, I'm not seeing what you're asking me.
That one? Not for the next line, you got 6 plus r.
Oh, if you want to get rid of a remainder, maybe I should have wrote my remainder this way, my fraction. If you want to get rid of a fraction in the denominator and get r by itself, you need to multiply every term by 2. I just kind of did that out here. I should maybe put parentheses. I usually do like a little arrow. Every term has to get multiplied by the denominator.
Plus or minus.
We're here. So every term has to get multiplied by 2 so that this can come out.
Yeah, I
Good?
enumerating
Okay, hang on. Question?
plus and minus 6 or is it just
Oh, no, just a minus 6. I just put the plus there because it was hanging around there. We're going to work this out in a second. Everybody okay so far? Okay, now, we have to collect these terms. This looks terrible. We never see an equation like this. So we have to distribute this. We have to FOIL this all out. Minus 1, minus 2, minus 3x plus 2, minus 6. Okay. And we have to collect our like terms. And here's your equation. Now, that x minus 4, where did that x minus 4 go? We had an x minus 4. We have a 0 of x minus 4. Look at your final answer. I hit my vertical. I got my slant because we worked it backwards. But where's my x minus 4? Look at your numerator. It factors into x minus 4, x plus 1, right? X minus 4, x plus 1. There's your x minus 4. See it? We don't really need to put it in when we start because you really have to work with your slant. Your slant kind of builds the whole thing. The slant works a little bit differently than everything else does. Let's give you a little minute. Where's a good starting point to get my function started? Vertical asymptote. That's probably your pointed discontinuity and vertical asymptote. There's your factors. What else do you know? A 0. And where does that go? Top, numerator. We're just going to leave that kind of sit there for now. And you know somewhere you did a division and you got x and a 2 and a remainder. So this came out to be your asymptote, and your remainder, should we use it, is over x minus 1. So this is our starting point. Okay. Yeah, divided by 1, but this doesn't come into effect. We're not going backwards on this. We're just working off of your slant. Do I have a point that I can use? An xy point. If I need to solve for r, that needs to be the only variable because I only have one equation. Do I have an x and a y I could substitute in there? Which would be what? Here's my 0. This is my x, this is my y. Sometimes they give you, usually they'll give you your x-intercept, sometimes they give you your y-intercept. And you substitute your y-intercept in there, then x would be 0. And y would have a value. So 0 is equal to, just substitute them in. Okay, keep this going. This stays by itself. Come on, it's not that bad. Let me make this. Can I erase? Oh, no, I can't. I keep making a slanted one. Maybe it's easier if I do it this way. So now I just multiply through by negative 4, right? Multiply everybody through by negative 4. This still gives me a 0. So what's r? Negative 4. Now, all I have to do is take this r and put this back in here. I found my r. Kind of like when you do your parabola, your a, x minus h squared plus k. You find your a, then you go plug it back in, right? This just takes a little bit of an extra step. Oh, I keep making a slanted one, sorry. So now, what's my common denominator? I only have one denominator. X minus 1. So my first term needs an x minus 1. My second term does not. And again, you've never seen us leave a quadratic looking like that, a function. So you work this out. And go one step further, collect your like terms. Set it equal to an equation. Don't forget to set it equal to an equation. So we end up with, let me write it up here. And where's my 0? Where's my 0? It's in the numerator. If I factored this, isn't that my 0 in here? Yeah. So the slant works itself out nicely. Yeah. It's just a little bit, you just got to get used to bringing it over here. The one thing that I know from the past, don't forget to put the x in here as well. Because what happens in the past, and I know from experience, are we given a 0? No, so we don't have any factors in our numerator. So we're given a slant asymptote, and we're given a y-intercept. So what is the point, the xy point for our y-intercept at -1? 0, -1. This is the guy I need. Okay? Now, at -1, I should be able to cover my x's and find my y-intercept. I have nothing in my numerator yet. So I'm going to start with my slant asymptote. When we did your slant asymptote, it ended up like this. And I had some kind of remainder here. This remainder went over my denominator. Okay? So if I can get back to my remainder, I should be able to build this equation. You're given one point. When y is -1 this time and x is 0, you're going to find your remainder. The x is over here also. Okay, what should we multiply by? Okay, now, we've got r and substitute it back in. Okay, we're kind of stuck. We need to get back to this. There was a reason why we did this. So we're going back to this point. Lose it too. This is a minus. Got a glare on from that window. Okay, so now, what's my common denominator? X minus 1. The first factor, the first term, he's the guy that needs the x minus 1. You see the pattern? Your denominator is what was over your remainder, and this one always just needs that piece. So now, FOIL this guy out. There's your perfect squares. Combine your like terms. We don't leave them. We collect everything. And make sure you set it to some kind of an equation. Now, look at our numerator. We have no zeros of the numerator. They would be imaginary. We don't have imaginary zeros in there. So we only work real on these guys. So we have no zeros. Makes sense. We have a vertical asymptote. Makes sense. I could work my slant back. I could put this in my y equals and put my slant in my y2. And you'd see that your slant guides your end behavior. Here's your y-intercept. Cover up your zeros. Cover up your x of 0. There's your y-intercept of -1. It all gets back to what you have. It's an easy way to check it. I like to just put it in my calculator because if this, especially with the slant, if or any of your horizontal, you can always put your horizontal in your y equals. You just can't put your verticals in there. But your verticals you can see from your table when it says error. Are we okay with this? Do you want to try a point of discontinuity one? How about do number 1? What else do you know? So what else? X plus 1. Where's it going to go? Numerator and denominator. Good. So now, my only other hint here is my horizontal asymptote. Somewhere I need to be like this. 1x, 2x. Well, whatever, x squared, whatever it turns out to be, but I need to have the same exponent. Up here I only have an x. Down here I have an x squared. So I need another x up here. Okay, so I need it to be 1 over 2. So I need this coefficient to be 1. Right? You don't have to put the 1, but just so that we see the 1 over 2. So now, I've got a point of discontinuity I have to worry about, so here's where my problem comes in. So take this out and put this in. Just take those out because it would be the same, it would just take you more work to plug the negative 1 in there. Use this point, x, y. When x is negative 1 and y is 2/3, I always make a slanted line. Cross multiply, resolve them and cross multiply. You're going to find your n to come out to be negative 1. Don't forget to go put it back in there and set up an equation. Okay? And check it. Your horizontal asymptote is 1 over 2, because there's your x squared. Your point of discontinuity, there it is, there's your negative 1. And your vertical asymptote is in the bottom there.
Why is it 1?